Are you convinced that your subject matter expertise about something is the exact thing that enables you to make better decisions about problems related to that subject? On the surface, it would seem that a strong background in something would mean that we would probably be better critical thinkers when facing decisions in that area. Actually, the fact that we have very specific knowledge in an area may be the thing that is standing in the way of examining the problem more thoroughly. Every thinking process a person might utilize is influenced by a well-known cognitive bias. As a matter of fact, if you look up cognitive biases on Wikipedia, you'll see definitions and explanations for more than 100 of them. If you're focused on developing and strengthening your ability to become a better critical thinker, you must take these known cognitive biases seriously. Throughout life, we have all sorts of well-known best practices and rules of the road that keep us from making critical mistakes. These cognitive biases are proven psychological pitfalls that stand in the way of making better decisions. Yet few of us know them as well as we know other best practice business rules. Simply put, a cognitive bias is a systematic thought process caused by our tendency to simplify information processing and then put it through a comfortable filter of personal experience or preferences. The cognitive biases fall into 6 main categories. We've got confirmation bias and hindsight bias and self-serving bias, anchoring bias, availability bias, and the framing effect. Awareness of each of these is important, but none more so than anchoring bias. That's because anchoring bias is the most common and often detrimental factor that impedes our ability to make highly effective critical decisions. Psychologists and researchers have long identified very simple methods of illustrating the debilitating effects of assigning far too much information to a single reference point and then anchoring our future decisions on that point. For example, researchers took a very simple mathematical equation that sequentially multiplied numbers 8 times and then presented it to 2 different groups in a different way. In the first group, they showed the equation as 1 times 2 times 3 times 4, all the way up to 8. And in the second group, they presented the equation with exactly the same 8 sequential numbers, but started in reverse order with 8 times 7 times 6, etc. After presenting the equation, they gave the respondents just a couple of seconds to make mental calculations and then asked them for their immediate estimate of the result of the equation. In every instance, when presented with the low numbers first, the respondents estimated a very low number as the solution for the equation. Conversely, the second group that was given the high numbers first responded with a very high number as the solution for the equation. Now, why is that? Well, quite simply, in the first case, the respondents could very quickly calculate that 1 times 2 times 3 was only 6, so they assumed that it wasn't going to add up to much in the end. That group guessed the median correct answer to be about 512. In the other case, the group got only as far into the numbers as the first group, but the number they came up with when looking at 8 times 7 times 6 was 336, so they assumed the answer was going to be a really large number, and they guessed the median answer to be about 2,250. Of course, the answer in both equations is the same, and the real result is 40,320. The first piece of information available and the quick calculations they made in their head led each group to anchor on that single data point and then extrapolate that relatively meaningless piece of experience to expect a certain outcome that proved to be incorrect. Most of us make this mistake in our critical thinking process regularly. This is just one of many examples of a known flaw that's scientifically proven to be present in our cognitive thinking process. As young children, we all learned all sorts of rules that are meant to keep us safe and help us make better decisions. We learned to look both ways when we crossed the road because the potential outcome would be so detrimental if we didn't. It's a very simplistic example, but it illustrates a very important point. If we know that the human brain and cognitive thinking process has built-in fallacies and pitfalls, and we know exactly what those key flaws might be, then why isn't the average person well aware of them? If you want to improve your critical thinking process, you should start by eliminating your natural tendency to anchor on an initial data point and begin to take in the broader perspectives before drawing your conclusions.